All right, welcome back to System Software. So today we are finishing up the programming environment. This section here, we went over the editor. At least you had a video for that, so hopefully everybody has taken... So who's done the tutor for at least Emacs or Vim? Who's done tutor? Okay, good. So hopefully everybody's comfortable with editing in their command line editor, at least, getting in, writing a file, writing text, saving it. We've gone over the build system last time, and the homework was to read more about writing makefiles and doing version control, and write one thing you learned about software engineering practices. So let me ask you, did anybody, what did you guys say for your reading? Yeah.
I was very surprised at how many levels of abstraction there are for the automation. Like that conversation with Socrates, where he was talking about, summed it up kind of well, where it's like you're automating the automation and automating that and automating that.
Yeah, there are tools that generate build files, right? There's there are several levels of this. These are really the kind of software ecosystem. The build and automation, build configuration and deployment automation is, especially today, there are tons and tons of automated tools. They are programs. We're programmers, so we write automated tools to help us do everything that we can. Yeah.
I learned that the shell's text can have other kinds of text to replace it, like expansions, such as variable substitution, command substitution, history substitution.
Yeah. The command line, right? The command line gives you all the features. We went over some of those, right? We went over some of the useful features of the command line. Yeah.
I didn't know, sorry. If you edited your code, that you could get a previous version back without kind of just saving it to the old version somewhere.
Absolutely. Yeah, we'll go over version control today. Yeah.
It's kind of but I've used environment variables in the past and just Googling, knowing how to set them up and stuff, but I never understood how they work.
Great.
The difference between shell variables and stuff, so that was an interesting thing to find out.
Yeah, great. And we'll actually encounter those a little bit. These are actually system managed by the kernel as well. So when we go to run an application, you actually tell what the environment should look like when you run the application. There are also some big vulnerabilities around environment variables. There was a bash, I think it caused remote code execution, because the bash environment variables could basically include code, if I'm remembering right, and you could use those. You can also use them as an exploit vector as well. All right, cool. Hopefully everybody read at least some amount and read about makefiles. Now, there was a question about makefiles and going over that a little bit, so let's do that. So what are your questions on makefiles from last time? I know I was a little delayed because of the projector issue, and I think I got through everything on makefiles, but I'm sure there are still questions. So what are your, someone asked, did somebody have a question on makefiles? You, right?
Yeah, but it was just I didn't understand at first. I just think I need a re-estimation of it again, just to get the general idea of
Okay, I'll do that. So I'll do that, but let's see if there are specific questions first, maybe I can motivate.
Yeah, more specifically on phony targets.
On phony targets, okay, yeah, I didn't go over this much. This is a pretty nitty-gritty implementation detail, a very specific thing in makefiles. So the reason that make has phony targets is because a target is meant to be a file that's generated. So one of your colleagues talked about levels of abstraction where you're generating stuff. And what the whole makefile rule is designed around is file generation. Code, or it could be code generation, could be documentation. But the tool that you have here in a rule is this target is supposed to be a file that's generated by this recipe. And then if there are any dependency, well, let me go to a simpler example here. So this is supposed to be a file that's generated by the recipe. So this is the recipe. The recipe is just a sequence of shell commands. This is the file that's generated. And then dependencies tell you what other files you need to generate first in order to build this. In this case, main is generated by the developer, but talking about levels of abstraction, if you have, particularly for compilers, you have C code generators as well as build system generators. And so this could be a case where you've got a C file being generated. And actually I think I have an example of this. Yeah, I've got an example of this. So this is an example of a makefile where is the C file? So this is an example of a rule where a C file is being generated. Same here. This is a recipe that it's a parser generator. We'll talk about this a little more when we get to compilers, but this is a tool that will generate C code from another specification, from another file, this .y file. And so when you go to when you go to build from the C files, the .o files from the C files, there's a dependency here on this C file, and then the make will set up this dependency tree as we talked about to figure out how to generate this file first, and it will use this rule to do it. Okay, so hopefully that covered a little bit overview again of the makefile system. So to answer your question about phony targets are just targets that don't have a file that you generate. They're just like names of targets that you want to be able to call from the command line. So you can say make clean. So it's just telling make that clean will never be generated as a file. And so basically you should always run this recipe whenever you call clean. And the reason for this is subtle, like maybe you have something that generates a file called clean inadvertently, or you touch it or something, who knows. But it's your makefile will still work as you expect, most likely, if you don't have these, but that's all phony targets are. Yeah?
This is just a tangential question, but are makefiles similar to like Docker files?
Docker file.
So Docker is for like virtualization management.
Yeah.
I mean, not really. It's really a different part of the software development lifecycle. That's more like deployment. Okay. I'd say makefiles are really oriented around building automating the build of the software. Docker is really more for deployment of the software. Now, you could combine them in various ways. You could have a deployment step in your build file. There's nothing. Oh, sorry. Sure.
Sorry.
Yeah.
Did somebody submit a ticket for this one?
Yes. So the HDMI cable is not working, but I have a workaround.
Oh.
So.
Okay. I just fixed this morning. I'm gonna have to recheck it and see what's going on.
Did you stop recording?
No, I didn't stop recording. So it's still not showing.
I can come
but,
back later.
Okay, all right, yeah, thanks. Sorry about that. Yeah, but I got to work around for now. All right, so I guess it was fixed. Maybe something else went wrong, but I'm still recording. Don't worry, I'm still recording. So Docker is different stage of the software development lifecycle. Once you get into like processes or probably senior design, you'll learn more about these other tools, other automations. So like software development lifecycle. I wish I had the picture up here, but these days, especially with large, mature software that's reused all over the place, a lot of the work of software engineering is in other parts of the very extensive development lifecycle, which includes building, testing, deploying, maintenance. There's also automated testing approaches, automated analysis, bug finding approaches. So a little different from Docker. Docker is largely for virtualization.
Did we learn about Docker here or no?
We're not going to learn about Docker here. No, we're not going to learn about virtualization. Okay, so other questions on make? So quick review of what makefiles are. They're really just lists of these rules for building files, for generating files. So the target is the name of a file to generate, and the recipe is the sequence of commands to generate it. So it's a lot like a bash. Like a bash script is just a sequence of commands you write on the command line. And so this recipe, it's just a sequence of commands that you can just enter into the command line. But instead of writing them yourself, you store them in this makefile, and then the makefile will run them for you automatically. And even better, it'll run them for you only when it needs to generate a new version of this file that you're trying to generate. So here's the basic example that I gave last time, where here's how we generate the main program. So just to make sure everybody's on the same page, this GCC command will compile and link these three source files, and it'll produce an executable called main. So in the Unix world, by convention, executables don't have an extension. You could certainly put one, because remember, the name of the file is not doesn't actually mean anything about the contents of the file. It's just a convention. So this is the program name being output by the compiler. Questions on this command here? Yeah.
So what, the dash O is saying like output it, and then like the main's kind of just like what directory to go?
No, this is the name of the file this is the name to use for the executable that's generated by GCC. So probably you run GCC like hello.c and then you get a.out, right? Everybody probably used to use a.out. A.out is the default name. So if you don't put a -o option, GCC just defaults to a.out. Yeah.
This is like for the assignment for instead of it being a make, just make.
Well, make would be confusing because make is the name of the program that runs make files. So yeah, so I think you're asking about how to run this. Let me go back to the Scratch directory. Yeah, I think I was here. So okay, so this is the same program. So if I run this on the command line, this is how you build the main program. So now I've got a new version of main. See, it was created right now. This should be the name of this target name should be the name of the file that you're generating in the recipe. Make doesn't check this for you, but that's the convention. The idea is that this target specifies the name of the file that the recipe will generate. So the name of this target should be whatever file is being generated here. So I could make a program called make, but that might be a little confusing because I have a program called make, and this doesn't do what make does. Now, I think your question is, how do I? When does this name get used? And so the arguments that you pass to make are the names of targets to build. So if you want to ask make to build this target using this rule, you give it the name of the target that you want to build. Does that make sense? So you give it the name of the target. So I think last time I glossed over this a little quickly where I just ran make. And so just like everything in the Unix world, there's a focus on good defaults to kind of make development faster. So if you don't put any target name for make, it'll default to the very first target in your file. It won't run all of them. It'll only run the first one. But to make it clear, if we actually, the defaults are hidden, and you wouldn't know that if you didn't if you didn't already use this already. So you can think of make as just taking all the targets that you want to build, that you want to run. So if I run make main, it will run this recipe. All right, other questions on this, the basics of this basic make file? And so then we talked about prerequisites. So this is the prerequisite section. So notice here when I run make over and over and over, it says, well, main is already generated, so I'm not going to bother trying to build it again. But if I edit one of these .c files, make will look at your prerequisites and say, all right, is any one of these files newer? So it'll literally look at the timestamp. So you can see here, the timestamp of main.c is 1219. It's later than main, the file that I generated. So what make will do is it'll look at all of the timestamps of the prerequisites and compare them with the timestamp of the target. And if any of the dependent files, the prerequisites, are newer than the file you generated, then it says, aha, I need to regenerate this because some of the files that were used to build it are newer. So I need to rebuild. So now when I run make main again, it will rebuild main. So actually, this is my version of make here, or make file is the advanced version where I do separate compilation, but it's the same idea. It's using these timestamps to determine when to rebuild a file. Other questions on this?
Well,
Yeah.
So you use a command like cat make file that just print all of that?
Yeah, so so if you review the lecture on command line usage, I go over this program called cat, which just prints the contents of a text file to the standard out, which is your console when you're running bash. What's that?
It's like different from like touch. Touch makes the file.
Touch creates the file. Cat will print the text of it to standard out. Yeah.
When I was doing the hello library, every time I ran, even if the like hello.c wasn't exited, it would still run. And it wouldn't do the
So without seeing your exact, oops. So without seeing your exact code, it's hard to diagnose why. Let's see. So maybe if you didn't have the dependencies. No, yeah, I don't know why without seeing your exact code. You can send it to me on EdStem or come to office hours and show me the code, and I can try to diagnose why it's rebuilding every time. Yeah, it's hard to see. Yeah.
Do we have to do like the object files?
For the Hello World one, you don't, because there's only one file. I just want to show you this, this notion of build automation and separate compilation, because you'll see this everywhere when you go into software engineering. But the Hello World program is literally one program, so you don't necessarily have to go through all this rigmarole to do this. So you could use this template for the Hello World, because all you have to change is the program name and the source files, and all the rest is patterns for doing separate compilation for you. But no, you could do what the 21st Century C book does and just have this super basic single target makefile, which hopefully everybody read that section. You'll see there's a very, very simple starting makefile that the book introduces. Yeah.
So at least for a program like this, what's the point of using variables?
For a program like this?
Our make all that simple enough. Do we even
Well, I guess it's a question of, I don't know, maybe a question of taste. I mean, you could do this. Yeah, you could do this. I guess it's just it's like a programmer style thing where you don't have sort of magic numbers or magic strings in your code. You can think of this. I mean, you can think of this as a program. Make is a programming language of sorts, and so just like in common programming style, you put constants in variables and then use them in code. So if you think of rules as like the statements in the language, and variables as variables like they are in a programming language, then it's like kind of nice practice to do that, I guess. You could also, another reason to do this is that some of these rules are actually built into Make. So I think this rule comes with Make already. So if you even omitted this, I think this would just work without this rule. I try it out and you can see. But some of these rules are built in, so you can actually avoid writing the rule. You could also include these or use this same template in every project you do and just change, just same principles as abstraction and programming languages is all I can really say to do that. But you don't have to do it for it to work. All right, everybody more or less good on Make? So the actual Makefile that you just need to make a Makefile for the Hello World project. You can be as expedient as you'd like if you want to do something as expedient as this, or as sophisticated as you like if you want to make a fancy version of the Makefile. But just some Makefile. I just want you some experience of doing that on the command line with your command line editor and seeing your source repository so you can actually clone and build it.
Are you making more Makefiles in future programmer assignments?
Yes. Yeah, you'll be making them on your own for the future projects as well. Yeah. Yeah, so the kind of classic, so the kind of minimal expectation for building a program from source is to be able to just do these three steps. So this is why I put this in the self-check for your homework, for your project rather. And you'll see this like all over. There's probably, I don't know, like thousands, hundreds of thousands of projects that follow this basic pattern. You clone from whatever source repository it has. It might not be Git, it might be some other version control. Go into the directory and you run some variation of Make. Maybe you'll do some configuration first. Maybe there's generated Make files. Maybe there's a different build system. But the ideal is that you just download the source code and then there's an automated process that will build the code for you. So what I want everybody to get the experience creating is source projects that are in version control that somebody else can download and look at all of the version history and they can build with a single command. They don't have to read through readmes. They don't have to struggle with your idiosyncratic build system that you generated or your idiosyncratic way of building stuff. They can just run clone, make, and done. Somebody else now can run your program. That's kind of the ideal here. Yeah.
Can you make that a little bigger?
Oh, yeah. So this is in the homework project. This is in the self-check. And this is literally what we do for grading. So one of the benefits here is that for automated grading, it's very standardized. We can just clone your repository, run make, and then grade it. And we don't have to read through specific README files about how to build it. Yeah.
What's the gitignore file?
We'll go into that. We'll go into that when we do Git. Yeah. Was there a question here? Yeah.
Were you talking about the assignment itself? Like, or is this?
This is this is an example from the assignment itself. But in general, if you just go on any Git project, GitHub project that's in, C or any language that typically uses C++ that uses make, or C, one of the makefile generators like CMake, the instructions will ideally be very simple. It'll be clone this, include any dependencies in your system. They talk about that in the 21st Century book as well. And then just run this program that will build it for you. And hopefully, if all of your versions line up and your system has all of the requirements that are, you have all the requirements in your system for the project, the program will just build. So in other words, don't impose on others some really complicated, convoluted process where they have to sit down and read through a long text file to get your program running, because they're probably not going to do it. They'll be more likely to do it if you have this very simple process for getting your program on their machine. All right, other questions on makefiles? So just do the simplest makefile you can, and make sure that next week when you submit this, that this process works, because this is literally what we're going to do for grading. We're going to clone your repository under your NID. We're going to enter the directory. We're going to run make to build it, and we're going to run hello. And if that doesn't work, and it doesn't work, it broke. So this is the grading sequence. So if any step of that breaks, then I've mapped this to points. But you should just make sure that this works. And also, this is a sanity check for yourself as well, because you've probably been in the situation where I'm sure this worked at some point, or I had a version of this that worked at some point. You may be fiddled with the code. You may have lost that code. And you may send it to, maybe you're working on a group project, you send it to your collaborator, and they're like, I can't get this to work. And you're like, I know this works on my machine. So I want you to go through the process of making a distributable, automated process for building and using your software that has checks for you, guardrails, to make sure that what you see on your machine and what you're doing on your machine is exactly replicable, or as much as possible, on somebody else's machine. Yeah?
You can, if we submit something and it ends up not working, so resubmit it
Absolutely, yeah. Yeah. So you submit it on time, submit your initial project on time, otherwise you cannot resubmit. Review the syllabus, review the first lecture. But then you can resubmit if things don't work. But the beauty of this build automation is that I can tell you exactly the sequence of steps we use to grade you, and you can replicate those steps for yourself. And we're all working on the same machine. So there's very little chance that if this works, you will not get the grade, except for human error or script error on our side, which we will, of course, fix. But you don't have to be, the great part about computing is you don't have to trust anyone else. You can do it yourself. You can try this yourself. You can prove for yourself whether this works. And these tools, these automated tools and version control tools, provide mechanisms to reduce the cognitive load of doing that. You don't have to remember what version of code you are on or whether something worked at some point. You can have a machine automate that for you. Then you can have very high assurance that your code will work as expected when somebody else runs it, including our graders. Yeah.
So basically, they copy all of these so the self-check, you have to copy all of these lines.
You just type these into the terminal. So this is just like a terminal session. You just type this into the terminal. You go to your home, once you're in Eustace. Go home, you clone your own repository, replacing an ID with your own name, go into the directory that was created. So and I'll go over this more when I go into Git, but you can ask Git to clone to a different directory name. It doesn't have to go to hello. And this is how your program should build and run. And this is how do I require clean here?
Yeah, I think so.
Yeah, I require clean. So yeah, just look at the notes, the lecture notes from last time. about using clean. I think I closed it. Oh yeah, no, here. Just copy this template or just add clean yourself. Oh yeah. No, change NID. Can I change NID?
And the name of our college, like
Everything else should be the same.
Everything else should be the same. Yeah. So this will create this git clone will create we'll download the repository from Gitolite, and it'll put it in whatever folder you give as the next argument. You can omit this folder, and by default, remember, good defaults, it's always part of the design, the Unix philosophy. We'll use the name of the repository as the name of the folder, but you can override that. You can change that default and give your own folder name. So if you do this twice, Git's going to complain that hello new already exists. So you can just put a different directory or delete that directory or move it. All right, so let's go over Git. This is one of the most, version control is probably one of the most important tools you'll use as a software engineer. I use it all the time. Not just for code, but also for papers. We write papers, and papers are in machine readable formats. You can use them for documentation. It's really a general purpose, almost like a file system, a snapshotting file system that will record the history of all changes that you manually tell it to record. Okay, version control. So version control sort of, basically all version control is a way to record changes to code. And really just any file. Most of these systems are set up to be just files. Source code is just text files. So version control records change to files. So why? Why do version control? Why bother recording the changes that you've made to source code? Yeah.
In case something goes wrong, you can step back.
Very good. Yeah. Something went wrong. You have a log of what happened. You don't have to guess or try to remember. You can go into your version history, check out a prior version, and see the difference, see what changed. Interestingly, you can also record who made the change, so you can blame whoever made it. And actually, Git has a command called git blame for telling you who's responsible for every line of code. Other reasons that you can think of, yeah.
Make a log, we can go back and forth on the system.
Yeah, so similar to what the colleague was saying, if something goes wrong, if there's a bug, and there are actually automated techniques, because you have this whole version history, there's a command in Git called git bisect, which will run a little binary search through the history to find which commit introduced the bug. So you have you might have thousands of commits, but if you remember binary search, you have the search space every time, and you can actually zero in on the exact commit, the exact change, that before the change there was no bug, after the change there was a bug, if the bug's deterministic. So sure, absolutely, yeah.
You can branch off from whatever the main thing is doing, so you can work on something without destroying everything.
Yes, and this is one of the key kind of features of Git is branching, and we'll show what that looks like. But you can have a divergent history of the source code. You can, and because Git is distributed, there's no internal notion of which copy of the repository is the real one, is the official one. There's really not really any technical notion of that. There may be a convention, social convention behind that. But you can fork, if you've ever heard of forking a repository or forking a project, somebody could just copy it and make their own history indefinitely. Or you can temporarily make a separate history so you don't mess up other people developing the project while you go and implement whatever feature or fix you need, even if you're maybe breaking the build or you're not really ready to release it to other people. And so one of the key, one of the reasons branching is so useful is because version control also allows lots of different developers to work together simultaneously. So if it's already hard enough for yourself, or myself really, to try to manage just a small project on my own and remember everything that's changed, imagine multiple people accessing it. If multiple people are trying to edit the same file at the same time, that's going to be a huge mess. So version control, one of the key features of it is it allows multiple collaborators, potentially thousands of collaborators to work, or even millions of collaborators to work on the same project at the same time. All right, other thoughts on why this is useful? Yeah. Yeah, that's a very good point. And so, absolutely. So not only, and we'll show this in a little bit, not only does it log the change, but it logs metadata about the change. So not only who did it, but developers write a message describing what and why the change was made, what the change was and why the change was made. And now these are tools that help you do this. You don't, if you're using Git kind of pathologically, you might just say change. But the way you're supposed to use it to have a good log that'll help you figure out what went wrong in code is to write good log messages. And I have a guide from Google Engineering who is very, very good at engineering, very good at software engineering, a guide here. Well, they'll actually tell you good recommendations for how to write these commit messages. You're going to be working alone in this class in your projects. You don't have to write, essays on each change, but it's good practice for yourself as well. And also there's good advice on what is a change. So in this class, you can really do change like whole file changes if you want, but Git has functionality to allow you to have individual lines of a file. So if you're working on multiple things at the same time, you can commit just part of the changes that you've made. But these are more advanced features. We'll get into this in this class, and I encourage you to read the free online Git book to learn more about this. But yeah, super powerful tool. All right, other thoughts on why use version control? So this is standard in the industry. I remember maybe 10 years ago or 5 years ago hearing a student saying, yeah, my job, they're still just like copying files around. I hope that's not common anymore. I mean, certainly for the big tech companies, version control is de rigueur. What do you mean?
Like whatever caused the big outbreak, like the
CrowdStrike. Oh, they weren't using version control or something? Is that?
That was like, I wonder if they didn't like resubscribe.
I haven't looked into that. What happened there?
No, they did like a kernel level BSOD stuff on Windows, and you wouldn't even go to.
Oh, okay.
They move and then do a whole thing, which isn't bad on its own, but when you scale it to like a lot of computers, that's when it's bad.
Huh. Okay, I'll have to look into it. I don't know if software engineering version control was related to it. All right, so that's why to use version control. So to give a little intuition about how version control systems, maybe not internally store stuff, but the kind of view you get as a user of a version control system is who's got a bank account? Does everyone have a bank account? So you're probably very concerned about your bank account balance, as I think most people are. When you probably go in, you probably look like, okay, I just want to know my total. But this balance says nothing about how you got there. So if you're ever shocked when you say, oh my God, why do I have like a negative 100 balance? That balance doesn't tell you about how that happened, right? Did I spend too much this week? Did somebody not pay me? So how do you know why your balance is your balance? What do you look at? Yeah. Yeah, you look at the statement of charges, the set of transactions. So that total is the sum of each credit and debit. So I got some income, $42. I spent money on gas, which is definitely more than this. Spent money on some food. I got a reimbursement for something. And so actually you can completely delete this total, right? You don't need the total now because all you have to do is add up the sequence of changes to your account and voila, you've got your total. So I could completely hide this and you can always recover the total by looking at adding up the sequences of changes. And well, I probably should have put dates here, but yeah, actually, now that I think about it, so these are also ordered by date. And so I can figure out how much I had in my account a week ago by just looking at all the transactions in the history up to a week ago. So I can say, well, at this point, okay, my math is really bad. So what's this, $27? So at this point in time, I had $27 in my account. Kind of makes sense? So with this transaction log, where you have a date, a timestamp, and a change, you can recover your account balance at any point in history. And so this is the same principle, if not the actual implementation, that version control systems give you, and this is the kind of high-level interface they give you, is each time you make a change in code, you can think of it as a transaction, as a difference that's made to the code. You add that to an append-only log with a timestamp. And so the state of your current code is just the sum of all those changes, the application of all those changes throughout the history of the project. Questions on that? Kind of makes sense? Okay, so this is what version control systems do. You tell it, here's the set of changes I'd like you to record, and you write a message describing what that change is. That's fundamentally, I think pretty much all version control systems give you the ability to do this. All right, so let's take a look at the classic tooling that actually a lot of this change management is originally based on from the Unix world. Yes, this one, right? Okay. So I've got an example here. Okay, so there's this classic Unix tool called diff. Diff compares files line by line. So if I get, so remember cat prints out the text of a file. So here is one file here. It's a simple hello world program. And here's another file, new file. What's the difference between these two? So I don't want to look at code, so I'm going to use the diff tool to tell me. But you're right, there's no include header. But instead of doing that yourself, there's a tool called diff, which will go line by line in the two files, and it'll report to you without, by default, it'll report to you only those lines of code that differ between the two files. So as your colleague said, the only difference here is there's an include, also an empty space, an empty line. And so it has, by default, it has this little notation where it's a right arrow for the right file. So the right file here is new file. So any lines that are in the right file have a right arrow. Any lines that are in the left file will have a left arrow. Yeah?
What happens if you do it the other way around?
Ah, good question. So what do you think happens if I do it the other way around?
Like red or something? It's like it's gone? I don't know.
Right, so they remove, okay, so yes. So good. So one of your colleagues said left arrow. So exactly right. So this default format for diff, this is the notation that it uses for the output. It uses left and right arrows. Now, it's funny that you said red because there is another, so this -u is this so-called universal diff format. I think I don't know why there's no color. You probably have to ask it to do color. I don't know. I don't know how to get it to do color, but yeah, where does color come from? What's that? To get color? Oh, I can ask it to do color. I don't know why that didn't work before. Okay, there we go. So there's just a flag to turn on color. So in this format, it will show you. So this is more designed for code because it'll actually show you like it'll show you the context around the change. So this is just a different format. You don't have to worry about this. I don't really show this in class, although the Git tool will show you diffs in this format. This uses a different representation. It just shows minus signs for removed code, and it shows plus signs in green if you turn on color for added code. So I just swapped the two files. So the first file is like the old version. The second file is the new version. And so in this format, it'll say, all right, green, this is code that's added, plus green plus, this is code that's added. And if I remove lines, it'll show red. Yeah. What's that? Oh, these are actually the line numbers in the file where the changes have happened. So I think this is the left file. And I think this is the right file. Is that right? So 1 to 3 and 1 to 5, I think. Actually, now that I look at it, I'm not sure. Oh, no, wait. I think this is mine. No, actually, I don't know. Yeah, you stumped me. I thought they were something to do with the line numbers, but I'm not sure.
Is this how we submit our files?
We'll get there. Let's look at the unified diff format. From file line numbers to file line numbers. Okay, so it is.
One has 5 lines and the other one has 3 total.
Oh, yeah. Let's just say that's what it is. 'Cause a line was added here to the first file, line was removed here from the first file. Oh, I see. It's because it's removed. Wait, no, actually, I don't know.
Because the old file had 3 lines starting from int, and then the
Oh, right. Okay. I guess that's it. Yeah. From file line numbers to file line numbers, and I guess it's line 1. Oh, yeah. Okay, it's the range, I guess. Right? Is it the range? 1 to 3 and 1 to 5. That sounds right. Oh, it looks like start and count. Yeah. It's start and count. Yeah. So start is 1, count is 3. Start is 1, count is 5, and then minus is the previous file, plus is the next file. Okay, but just So, and this is other metadata about the timestamps and the names of the new and old files. All right, so that's the diff tool. The diff tool will show you automatically what lines have changed between 2 files. Questions on that? Questions on the diff tool? So can you imagine how you might start building a version control system using diff? And like the bank account transaction history, you actually don't even need to record the file. You can just record the sequence of diffs, and some older version control systems actually work this way. And so we can actually save the output of diff. I'll save it into a file called change.patch, and I think patch is flexible about what the format is, so I'm going to use the old format, although it doesn't really matter. And so here is a file that I've created called change.patch, and there's another tool called patch. Patch takes in your old file, so I'm going to make a copy of my old file. So I'm going to call it file.c. So file.c, this is the contents of my old file, right? No include header. And patch is like is it the inverse of diff? So if diff takes old file, new file, produces patch. Patch takes old file and the actual patch file and produces the new file. So I gave it patch, the old file, and the file holding the diff. Maybe I should have called change.diff, but this is the file holding the diff. This is the old file. It will rewrite the file to update it using the diff file to produce the new file.
You can do that with multiple files?
You can do that with, absolutely, you can do that with multiple files. So there's a recursive version of diff. So I've got these 2 file trees here, although I only have 1 file in them, but you can do this recursively over an entire, actually there are 2 files in there now, but you can do this recursively with R over an entire source tree or entire file tree. So here it's recording the fact that there's a file that didn't exist. Yeah.
What happens with conflicting changes?
Oh, that's a really good question. Conflicting changes. We'll get there when we talk about Git. So here we only have a single change, so there's nothing to conflict with, right? But if 2 people have made changes and the diffs, if you're applying both of them, messes with each other's changes, how do you deal with that? So Git has nice ways, if not very fine-grained ways to deal with this. Actually, multiple ways to deal with this, and we'll go over that. We'll go over that in a little bit. Let me check my time. All right. So this is diff and patch. This is the basis of version control because diff records changes, and if you record a series of changes, then you've recorded the history of the versions of a file. Okay, so you can think of a version history as just a sequence of these diffs, just like a bank account balance. Any questions on this so far? Yeah. So if diff takes 2 files and gives you the changes between the files, patch allows you to take the old file. Patch allows you to take the old file and the changes and recreate the new file. Does that make sense? Let me show this diagrammatically. So diff takes 2 files in. Let's call them F1 and F2. It takes in 2 files, and it produces a change. It records the change between those two files. So what patch does, patch takes in the patch tool will take in the old file and the change, and it'll recreate the new file for you. Does that make sense? Yeah? All good? Okay. Yeah, so that's diagrammatically, that's what diff and patch are. Yeah. Say again? It's a good question. So there is a flag in patch that will unpatch. It'll like do the inverse of the patch. So to show this diagrammatically, it's capital R. You could also give the new file and the same change, and it'll give you the old file. Yeah, so you can unpatch as well, but don't worry about that. It just reverses the pluses and minuses basically. But yes, you can unpatch with the patch tool as well. Okay, so that's diff and patch, and a version history you can think of it as a sequence of diffs, conceptually at least. All right, so enter Git. Git is a version control system for recording these sequences of changes, these versions, different versions of source code. And the lingo is repo for repository. Repository is the database of those versions. And Git has some nice features that make it useful for large-scale development. One, it's distributed, which means you can have multiple copies of the database, and you can synchronize these multiple copies. So if I clone Git repository, if I clone, say, the Linux repository from the kernel.org, I'll have a full copy of the entire history of the Linux kernel development, from when they started using Git and whatever they've added back. You can also create branches, which we talked about. So you can create your own history, and if you like, you can merge that history back into whatever the main development history of that project is. So distributed, this is a graphic from distributed. This is from the Pro Git book. There's an online free book from, I think, the Git developers. So this is what it means by distributed. You can have multiple copies of this database on different computers. So there can be two different users. You can, if you like, you can have a server record the official version, although you don't have to. You can use it in a decentralized fashion. And so everyone has a complete copy of all versions of this source code. And you can do branching. So if each one of these C0, C1, these are changes, these are commits that record the change with a message. So this is the first commit, this is the second commit, the third commit. You can have multiple forked histories on this source code. So this master may be the main branch, the master branch, the kind of official branch. By default, it's called master. You can make a new branch that adds some bug fix and some other branch that adds some new feature, and you can have these branches live at the same time. Maybe they're on other people's machines, maybe they're on your machine, maybe you use multiple branches in your development. And so branching is one of the key features of Git, that you can very, very easily and quickly make a branch, because all a branch really is just a name that points to a commit. And because all of the commits point to their prior version, you can have as many trees. If you've ever looked at blockchain, it's like blockchain, where you can have multiple histories that all have a shared common history by following the chain. Questions on this? This is really just a linked list that has multiple heads to the list. That's really all you could. That's one way to think of this. Think of branching, linked list with multiple heads to the list. And in fact, in the lingo of Git, the head is the first or the last commit to the branch. It's called head. And in order to resolve these multiple histories, you can merge branches. So here's a case where you have a merge commit here. The merge commit just has pointers to both of the histories. And now in practice, if you have merge conflicts, you have to resolve these yourself before you can create this merge history. You won't let you create this merge commit until you have commits that can be merged together. And so Git has automated merge tools. They have this thing called a three-way merge where they will try to automatically find a merge that allows all changes. Basically, as long as they're not being changed to the same file or the same line in the same file, then you can automatically merge, more or less. Okay, so these instructions are in the Hello World project as well, but make sure after you log into Eustace that you configure your Git repository. Let's see how much time I have. Okay, yeah, not too bad. All right, so I think I've already configured this myself in Eustace. So make sure you put your full name, your email, and importantly, put the editor that you chose to use, Emacs or Vim. Configure the editor, because when you go to do commits, it will pop open your editor for you to allow you to write in a commit message. Yeah.
Do we do that every time we go into Eustace?
No. This is a one-time configuration, which I hope I make clear in the Hello World. Yeah, this is a one-time. So I don't make it clear here, but yes, you only have to do it once. So it's stored in a file in your called git config in your home directory. And so you only have to do it once, and it just creates this file. Yeah.
If I want to change my editor, like COP-3402, then I should configure it.
Yeah, you just run this command again and put in your new editor name. Yeah.
It says that I can't, there's no such file or directory in as cat git config.
There's a dot here. I don't know if you saw the dot here. So if you type this,
I did.
then you may not have configured Git yet. So once you run these commands, you'll have configured Git, and that file will appear. So run these commands. It's in the Hello World instructions in the Git section. Run these to configure Git. Yeah. All right. So let's go over some of the basics of using Git, and you can follow along at home. I'll just go through a very simple example, and you can actually create this example yourself by putting your own NID here. So let me create a new repo. Okay, so this is what you see when you clone an empty repo. So I changed directory into the folder that stored my repository. So git status, this is something you should be running all the time. This tells you whether you've made any changes to the repository. So here it says, I have no commits yet. I can add a new file. So remember, echo just prints out whatever the argument is to the command line. I use redirection to create a new file. So I've created a new file called readme here that just contains the word example repo. Git add will stage this file to be committed. And if I look at git status, it'll tell us, here's some changes that you've told me you want to commit. And then to actually create the commit, you run git commit. And in this case, I'm going to show you just putting the name of the file. So what this will do is it'll commit all of the changes in that file since you've staged the file. For this class, that's probably okay. If you're in a professional setting, you'll want to commit individual lines of your program, and it's much easier to do it with like an IDE. There are tools to integrate this in Emacs and Vim called Magit and Fugitive, I think it's called. I showed this actually in the editor lecture using the Emacs integrated version of this. So this will create the commit, and when you run git commit, some people may have seen -m for writing commit message. I consider this bad practice. And so if you look at like Google's engineering guide, I would call that bad practice. Just run git commit and the changes that you want to commit. And your editor will pop up. So the reason for this is that your changes may not be describable very easily on a single line of bash. So here I've add readme to the repo. And then the convention is you add a space and then some explanatory text explaining more details about the change or why you made the change. This was an empty repo. So I created an initial commit of a readme. And so this is a very much a toy example. But if you look at professionally maintained Git repositories, you'll see detailed commit messages. And so this is why it's so important to know your editor. So because it'll pop up your editor automatically, and if you're confused about how to use your editor or quit your editor, you're going to get stuck. So if you know how to use your editor, you save the file, quit, and Git will take that file and create the commit for you. So it tells us here, some details about the commit. And so if you want to confirm that this has happened, there's a few things you can do. You can run git status, and it says nothing to commit, working tree clean. So no changes have been made right now. If you want to actually view the sequence of metadata about your Git history, you can run git log. So git log shows a lot of things. Every commit has a unique ID associated with it. It will tell you the author, the date it was created, and here is my commit message. So when you have a long commit history, like if I show you, for instance, there's the Linux kernel, and I run git log, you can see they are very, very detailed in their commit. So this is a merge commit by Linus himself that gives great detail about why this commit was made, or why this merge was made. You can actually search for, oops. So you can see here that these are lots of merge commits here. But if we go down to a non-merge commit, so this is a commit made by this author Dave here. Actually, this is a revert commit. He undid something. But you can see that these professional developers have very, very detailed commit logs that they're using to explain why these fixes were made. And you'll see, for instance, fixes to CVEs, security vulnerabilities, very detailed descriptions of what this fix was and why it was made. Yeah.
Can you show that one more time?
Which?
Like the commit part, like what you type in the other.
Oh, sure. Yeah. So let's do another commit. So let's edit this README file here. So I've edited my README file, which you should all know how to use your editor now, at least the basics of opening, adding text, saving, and quitting. So I've edited my README file. So here's my README file. I've edited it. And if I want to commit all the changes in the file, stage and commit all the changes in the file, I say git commit and the name of the file. So as I said, in practice, you should be committing individual lines, but for this class, it's fine to just do the whole files. So as soon as I hit enter, it pops up an editor for me. This editor contains some instructions and some information about the commit. Everything as it says here, everything with a hash symbol comments will be ignored, will not go into the commit message. And the convention is to have a subject line here, or a summary line here, add more detail about the project, and add space and add a paragraph here. Now, you may not always need to add the great kind of detail that, say, these Linux developers are adding, especially for a class project. But it's just a file. It's just a file, and this is the name of the file. It's called commit edit message that Git manages for you. And then you just save it. So I just did, Control X, Control S in Emacs, Control X, Control C to quit. And once I quit, Git will take the contents of that file and it will attach it to the changes I made. Is that clear?
What I did was I just opened the file and then I didn't realize I literally just typed in the bottom and then the file name again.
The file, you just put a description of the commit. You don't have to name the name of the file. You don't have to rename the commit message. You just put a description, save it, and quit, and Git will manage that for you. So when you type git log, we'll now see that there are two commits. So the latest commit is at the top, and the next commit. And this is just the metadata of the commits here. You can actually view. So this is the unique ID of the commit. If we copy one of these commits here, the git show command will show you the diff of this commit. It'll show you all the metadata as well as a diff to show you what changes were made to all of the files. And if there are multiple files here, it'll show you the changes that were made to all files. By default, if you run git show, it'll show you the latest change. the latest change is also aliased to the head label. And so I can also, if I look in my log, oops. If I go back to my log here, if I want to see an older commit, I can copy this older commit, run git show, and you'll see the contents of my first commit here. And you can, you don't have to remember all this now, but there are like little shortcuts for viewing. I can view the second to last commit by adding a tilde. Can view, but don't worry about the details of these. All right, questions on this so far? The basic commands. Git status to see if you have any changes. So if I edit this again and I run git status, it'll tell me I've got some modified files that are not yet ready to be committed. And so this is if you think you've submitted your project and you run git status and you see this, we will not see these changes with these changes made. These are only your local changes. Yeah?
If I did a commit under different config information and I want to change it to another commit, like does it auto-update it at all?
No, the commits will not be updated. Think of it like blockchain, where it's they won't be updated. Now Git does allow you to change histories. You can actually go and do that.
So you can't just go back and say like.
No, because the hash code I think is based on the metadata, so it's like append only. You could rewrite the history, but then you'd have a different history, and you'd have to, if you're working with other people, you'd have to get them to accept that history. So no, yeah, if you messed up your metadata and you put some name in there that wasn't your name, there are even mechanisms today for having authentication of who is making the commits, because you could just lie, right? You could just say any name you want. But there are ways you can include basically a digital signature as well to authenticate. But yeah, good question. But yeah, Git. Some people complain that Git allows you to sort of modify history, and that's sort of true because yeah, you could, but it's rewriting the history, so you'd have to get others to accept your new history. All right, any questions on Git status, Git add, Git commit, and Git log? All right, so I know there's a lot of commands here, and I just want to show you kind of the high-level design of Git and where all these commands fit in. And I don't expect you to kind of remember all of this or know how to use all of this. So at the end, I'm going to give you a very basic workflow that you can just copy from every time you're going to grade your project. But to help you understand what all these commands do and why they're there, let me give you some information that's basically from the ProGit textbook. So the design of a Git project, if you have one Git project, when you clone a project or you create a new project, there are three pieces of that project that are in that folder. The first is the working directory, and this is your copy of one version of the project. This is what you think of as your source code. This is all the README file, the source code, the .c file. This is all of the code in your project. And the working directory is where you can check out different versions of the project if you like. When you clone a project, the working directory defaults to the latest change. But this is the snapshot of the version of your project. This is what you're going to be editing and working with. The staging area allows you to collect changes together before you commit them. Now, why would you want to do this? Why wouldn't you just commit? Why would you want to stage commits? Yeah.
Make sure it works first.
Oh, well, I think you'd have to commit to do that. I mean, you'd want to make a separate branch to do that. Yeah. Well, code review is also interpretably done after commits. Yeah, so why would you want to so you as a developer, commit is when when you commit it, you add it to the log, and then if you have other collaborators, you'll share that log with them. But why would you want to bother, not just saying, well, just commit this whole file every time, like we did on the command line? I think you were next up there. Okay, yeah, so you may have a lot of changes in your working directory, but not all those. You may not want to commit all those changes, and you really shouldn't. You may have fixed multiple bugs, or you may have been adding a feature and then found a bug that you fixed. And if you read the Google guide, and I'll link to it, on making good changes, making good change loggers, you shouldn't merge those together. And in fact, if you work at a place like Google or one of these bank companies, during the code review process, when in order to have your collaborators accept your changes, they're going to review your code, including testing it, including looking at your commit messages, including looking at the code that was changed. And if you give this massive commit that just commits hundreds of lines that fixes 10 bugs, and you say, fixed a lot of bugs, they're just going to reject it. And you're not going to go into their official code repository. So staging is when you're doing professional development, staging is an important part to collect together only those lines of code that you want to put in your well-crafted, well-described, well-justified change. And so staging area allows you to do this, where you can have lots of modified code, but you only, and I know I've done this many times in my own code, where I want to break down the changes I made into separate pieces so that it's clear what happened, so that I'm not just shoving a whole bunch of stuff into one commit. So that's what staging is for. And then the repository itself, it's actually not in your main directory, it's in a subdirectory called .git by default. So if you look here's my code is in this directory, just literally a snapshot of the code, and then there is a subdirectory here called .git, which contains compressed database of all of the files and all of the snapshots of all the files in your entire history. Yeah. I don't think there's any size limit. No, I mean the size limit may be your directory size limit. That's a good question. Can you partially clone? Yeah, you can. You can actually. I think you can. Yeah, you can. You can ask. So it's getting into the weeds a little bit, but the Git book makes it very clear that it's not a delta base. It's not literally storing only diffs. It stores snapshots of the entire tree, but it uses tricks behind the scenes like storing only diffs and pointing to the previous file. So I don't know what Git does under the hood, but you can ask it to only check out clone the latest branch. And I think behind the scenes, it'll just download whatever data it needs in order to reconstruct that. So it may end up downloading more than just that branch, but I think it probably will optimize away from that. I'm not entirely sure the internals. But yeah, you can ask it to only get part of the history. Whether it actually gives you, a subset of the database, I'm not sure. Okay, so those are the three pieces. And so when we do operations like stage, commit, checkout, so when you clone your original project or you say git checkout to get a different version, it's taking the data from the Git the repository itself, the Git directory, and it's moving it or checking it out. I mean, it's uncompressing it and copying it to the working directory. And this is where you're actually going to be editing files, making changes to your code. When you stage fixes, there's a separate place in your tree, I think it's under like index or something, where it'll keep track of all of the changes that you've made. And then when you commit, it moves those changes into a new commit with a log message and stores it into the repository. So this is how these three pieces work together. So these are the operations that operate on these different areas. So add is what stages a file, remove removes a file from tells the staging area to remove a file. Commit is what does move files from the staging area to the commit. And then you use your editor or whatever to modify files in your working directory. So you can review these at home or look over my basic workflow that I've given you. And these are the different states of files. So they're either not in the repository, they're unmodified, they're modified, or they're staged. I'll let you guys look at this yourself if you want to look in detail about what each of these operations do. I've already given an example of committing. You can also use diff to look at what has changed between actually this is a useful tool, so if you've changed stuff in your README, for instance, so if I add a new line to the README, then git diff will show you what has changed. So this is nice to pair with git status. Git status will show you that a file has changed. Git diff will show you what has changed between your working directory and the last version. You can also compare multiple versions of the file. Okay, so last bit on the remote part. So for your project, we have a very, very simple architecture. There are only 2 repositories. So remember, it's distributed. We have a copy on Gitolite, the Gitolite server, and you have a copy on your Eustace account. The project submission is just using Git's tools for synchronizing these 2 different repositories. And so we'll just use the exact same tools that Git has. When you clone, all that happens is all the commits are copied to the 2 machines, and there are these pointers that say, hey, this is my view of the remote machines branch, and this is the review of my local machines branch. Yeah? Yes. All right, so let me switch to the project since we only have 4 minutes left. Let me switch to the project itself and go over the project itself. So this is assuming that you've already done the first step, creating the Hello World program, and assuming that you've created the makefile already. This shows you all the commands you're going to need to run in order to submit your project. So do the one-time configuration of your Git tool in Eustace. And then inside of your Hello folder, which is where your program, your script, and your makefile should live, Git init will create a new Git repository for you. It'll create an empty one in the .git folder. And use git add to add each of these files into your repository. And use git commit in order to stage them into your repository. And then use git commit to actually make a commit. So, git ignore, I gotta go into git ignore. So git ignore all right, so let me do the sequence of steps here. So I've done git init, and let me add hello.c. What else do I have in here? Hello timing, hello.script. I don't have the makefile yet. So the reason we have git ignore is that if I go to build this, let's say I compile hello.c, I now have this hello.o file, but it's not a file I want in my repository. So one of the main conventions of version control is to not store generated files or binary files. They're large, they can be regenerated. So the problem is I've got these additional files that I don't want in my repository, but every time I run git status, it tells me, hey, you have these files here. So what git ignore does is it maintains a list of paths to files that you want to tell Git to never consider as part of the repository. So when I put hello.o, or if I do this with Git or with Emacs, I put hello.o in this git ignore file. I can also put the program hello in here. And when I run git status, it'll no longer complain to me that hello.o has not been tracked by my repository. So now this git ignore file is something that you want to track because you want other people who use a repository to also ignore the same files. So if you're an Emacs user and you want to ignore these backup files, you can add those as well. Or a little trick is to use a wildcard to add them if you're an Emacs user. So now I've modified git ignore. It no longer considers this file as part of my repository, but I've modified git ignore, so I'll need to make another commit to my repository. So the main key here is that when you run git status, network issues. The key here is that when you think you're done and you run git status, that should be clean. That should be empty. There should be nothing to commit. And when you go to clone your project, so if I clone my hello project into hello new 2, I only want to see these files in my repository. I don't want to see hello.o. I don't want to see hello. No binary files. That's why This is very specific about the grading only contains the 5 files that are required for the project. So I want you to use git ignore to exclude those generated files, those binary files, from the repository. And then, when you want to do the submission, you add this remote repository. So you just follow the instructions here to add the remote repository, and then when you do git push, and you can just cut and paste these, changing your NID. This is what will synchronize your local repository. Yeah, because I already have this done. Uh-oh. Yeah, so I already have hello there, so it's refusing to let me push it, but that's what git ignore is for, and this is what your state of your repository should be whenever think you're finished. You should be able to run git status, nothing's changed there, and run these commands in order to verify that what we see is what you think we see. All right, thanks everyone. Sorry for going a minute over, and go on EdSTEM to ask questions. Come to office hours, and talk soon.